The next industry which is using AI is smart city, and I will introduce the following aspects. In 2008 and 2009, IBM put forward Smart Earth and Smart City. The so-called wisdom of IBM is to use intelligent sensors for better eyesight management and logistics configuration, helping users develop better operation solutions. In the Hannover Messe 2013, German's Industry 4.0 work group mentioned the following in the German industry strategy plan. In an intelligent, networked world, IoT and IOIs will penetrate into key areas. Today, smart city is not only networked, but also intelligent, and supports proactive operation instead of passive connection. The idea and vision of smart city is to think of the city as an ecosystem. The citizens, transportation, energy, commerce, communication, and water resources in the city constitute individual subsystems that are fully connected and mutually influenced. Sensor devices become the awareness organ of the city. The IoT and iOS become the neural network of the city. The data and intelligent platform become the brain of the ecosystem. If we consider the smart city as a person, sensors that provide perception functions are like sense organs. The networks and connect sensors are like nerves. The cloud technology that controls and stores information is like a central nervous system, and big data is like brain. And then I will introduce some key technologies in smart city. The first one, perception technologies. Perception technologies are divided into sensor and wireless sensor network. The perception technologies are developing in the direction of high performance, low power consumption, micro miniaturization, and low cost. It provides the development space for various applications of smart city. By means of perception technologies, information such like indoor temperature, humidity, smoke, road vehicle information, and city traffic status can be quickly obtained and analyzed. It is convenient to take countermeasures to carry out long-term planning. Sensors are classified into physical sensors and chemical sensors based on working principles, and are divided into general sensors and intelligent sensors based on the automation degree. Sensors in a smart city solution are responsible for simple scenarios of data collection and transmission. For example, environment parameters are automatically obtained for environment monitoring. The wireless sensor network, what we call WSN, integrates sensors, processing units, and communication modules. The nodes forms a distributed network. The connected data is optimized and then transmitted to the information processing center through radio waves. The new generation wireless multimedia sensor network can obtain temperature, humidity, light, intensity, and pressure data, and use videos and audios in medical surveillance, traffic surveillance, and smart home scenarios. Next one, the network capabilities. The breakthrough of network technologies make the efficiency transmission among massive nodes possible. Smart city reference includes human communication, behaviors, and unattended communication scenarios. That is, IoT communication scenarios. IoT gateway is used for connecting a sensor network and a traditional communication network. What is Internet? And implementing protocol conversion between a perception network and a communication network. IoT gateways are widely used in intelligent transportation, lighting control, government work, intelligence, firefighting, public safety, environment monitoring, health care, and food source tracing. With the rapid development of mobile internet and IoT, and explosive increase of the demand for IP addresses, IPv6 provides larger address space, smarter routing tables, stronger multicast support, and higher security. It becomes an important technology for future Internet or IoT development. The third one is cloud computing. Currently, many applications involved in smart city are distributed in multiple locations and are isolated from each other. An ideal smart city architecture should have a public service platform that provides common capabilities, such as data management, capability invoking, business process customization, and maintenance services for various industries. Cloud computing technologies cooperate with the public service platform of smart city, provide various capabilities. Regarding basic resource sharing, the visualization technology is used to improve the utilization and deployment speed of the underlying computer, storage, and communication resources of the IoT platform. Dynamic scale expansion. Computing and storage resources are abstracted and consolidated, and the infrastructure is dynamically adjusted based on services to implement elastic scaling of computing resources. Intelligent analysis and processing. Distributed computing and storage are used to process massive data. In smart city applications, cloud platforms such like municipal cloud, transportation cloud, education cloud, security cloud, and community cloud have been deployed. Service applications and data are being deployed in a centralized manner. Big data is a key technology that enables intelligence in all fields of smart city. Smart city is evaluated from 6 aspects: economy, governance, life, people, environment, and mobility. Smart city is mainly applied to logistics, transportation, power grid, industry, agriculture, building, environment, and healthcare. And these fields involve government big data applications. Smart city construction will bring explosive growth of data. After a series of smart processing, such as classification, restructuring, and reuse of big data, the resource will be used in all aspects of big smart cities. Government decision-making, services, people's lifestyles, and the city's industrial layout and planning will become intelligent. In this part, I will introduce some typical application scenarios of smart city. City Operations Center. The city center is the basic platform of smart city. Resources are centralized through the unified cloud data center. Typical scenarios are department data sharing, basic city database, information portal, and unified view. Emergency command center. The typical applications of the emergency command center are as follows: unified alarm receiving, per event warning, alarm linkage, and centralized media control. Safe city. Safe city aims to transform from human-relied safety protection to technical-relied safety protection. The main modules are as follows: checkpoint management, radar speed detection, e-police, video surveillance, and emergency handling. Smart governance is also an important field in smart city. E-governance is an intuitive manifestation of smart government, which facilitate honest, pragmatic, and efficient working of the traditional government. Smart government mainly includes e-government, intranet and extranet, online approval, public information service portal, and so on. Smart park. Smart park uses a new generation of information technology to change the interaction mode between governments, enterprises, and the public. It provides virtual desktop cloud, smart card, intelligent patrol, and intelligent parking lot. Smart transportation integrates technologies such like electronic, information, control, and vehicle technologies into the traffic field to improve the traffic conditions. The service include violation capturing, road speed detection, vehicle detection, transportation management, intelligent bus, and comprehensive traffic information services. Smart environmental protection includes ecological protection, resource utilization, and soft environment construction, and so on. The services include environment monitoring, data aggregation, dangerous mobile source monitoring, water quality monitoring, environment air monitoring, and system decision-making support. Smart education is to promote the sharing of high-quality education resources by using information technologies and to achieve all-around learning and lifelong education anytime and anywhere. The main scenarios include campus, informatization, online remote education, interactive education, e-class, and so on. And then, let's see some smart city application cases. In 2009, New York announced the launch of the City Interconnection Action and passed the Open Data Act in 2012, which was the first time in American history to legislate for government data. New York has initially established an ecosystem based on urban social operation data, which is the most promising practice for smart cities so far. In 2005, New York started the electronic health record system, which greatly improved the record query efficiency. Through broadband access to campus, automatic library, and the intelligent management of teaching information are achieved. The traffic monitoring system monitors the changes of all traffic status in the city and provides the best route suggestions for citizens. The New York City 311 call center helps reduce the call traffic of the 911 hotline for the first time in 34 years. The second case is Tokyo. In 2007, the Tokyo municipal government and the Ministry of Land and Transportation jointly launched the Tokyo Anywhere Plan to implement IoT applications across the city. A wide range of ID identification technologies are used to assign identifiers to locations and articles in Tokyo. Users can use mobile devices to read entity locations or information labels on objects, and the devices digitalize information or content in the real world and combine the information with that in virtual reality space, so that the users can obtain comprehensive information services. In addition, the Green Tokyo University program uses sensors and IPv6 protocols to connect multiple subsystems, such as air conditioners, lighting devices, power supplies, and monitoring systems, to form a well-compatible system for intelligent analysis and the effective configuration and management of electric energy. In Vienna, the drainage pipe network was restructured using intelligence technologies. 230 monitoring equipment was installed in the 2,400 kilometers drainage pipe network. The flow rate, flow volume, and water level of the sewage were monitored in real time. In addition, 256 gates and 85 pump stations were established to control the flow rate of different pipes networks, so that sluice gate can be established to control the flow rate and volume over different pipe network nodes. The Viennese Pipe Network Company is connected to 24 weather stations and is targeted at the weather and blockage conditions. It takes only 20 minutes from the time the control center issues the command to the time the gate of the pipe network is opened or closed.